Hello and welcome to PA Academy. So in the previous video we've looked at current divider rule, and right now we're going to talk about voltage divider rule. So if you missed that part on current divider rule, kindly check the playlist. You find a link to that particular video. Alright, so for current divider rule, just like the name says, voltage divider rule. So that means we are dividing a particular voltage, and the idea behind the voltage divider rule is gotten from resistors connected in series, like you can see on the screen. So from resistors connected in series, like I said when I was explaining it, I said if you have the resistors connected in series, the same current is flowing through them. So that means, using this as an example, our I total, which is our IT subscript, so that means I subscript T, which is the total current, is the same thing as our I1, it's also the same thing as our I2. So that means the current that is coming at this point, if it is 5 amperes, the same 5 amperes is flowing through R1, the same 5 amperes will be flowing through the second resistor. So that's what that means. Okay. However, the voltage are different. Exactly. So the voltage through this R1 resistor is indicated as V1, and the voltage through the second one is V2. They are different. They are not always the same value, all things being equal. So now the question now is, how do we now know the value of V1 and the value of V2? So that's where the concept or the idea of voltage divider rule is exactly. So we have to divide the total voltage that is flowing alongside this IT. So at this point we are having our VT also. How do we now know, okay, how many of this VT? Let's say our total voltage is 5 volts. From that 5 volts, how many of that 5 volts is flowing through, or if at this point is 5 volts, if 5 volts is flowing through here, then how many will get to this point? Exactly. So, or for V2. So that's just the basic idea behind it. So now let's look at how we can use that, the idea of voltage divider rule, to get the value for V1 and V2. Now let's make reference to Ohm's law. So from Ohm's law, we know that, so let me write it down. From Ohm's law, we know that V is equals to IR. Exactly. So that means we can say our VT is equals to our IT and then RT. Don't forget, I mentioned in the previous videos that if I say RT, I'm still making reference to REQ. That's the total resistance or the equivalent resistance. So if I say IT, I'm still making reference to I equivalent. Exactly. So I'm still saying the same thing. So that means from here, I can correctly say that our IT is VT over RT. So making reference to it with this diagram is that means the current at this point is VT, which is the equivalent or the total voltage. Exactly. That means the addition of V1 and V2 over the total resistance. Exactly. That means R1 plus R2. Are we good? So we can also say that since we've already established that our IT is I1 is also equals to I1 is also equals to I2, we can also say our VT is also equals to V1 plus V2. Exactly. So that means the total voltage is V1 on V2, and then our RT, remember that this is resistors connected in series. So for that of series, that means our R is going to be R1 plus R2. So now let's take note of what we are having here. So what we have just done here is this VT, so this is it here, and then for RT, this is it here. Okay, so now let's try and see what V1 will be. Exactly. So remember, we've also said from Ohm's law that V is equals to IR. And if you are to use this to make reference to this particular resistor, so we can say that our I1, so our I1 will be V1 over R1. So now let's compare what we have here with what we are having here. Exactly. And remember, we said our I total is the same thing as our I1, is the same thing as our I2. So we can say that since our I total we've established is VT over RT, so we can write that VT that's our total voltage over RT, is equals to our I1. Remember, they are both the same value. We've explained that. Is also equals to V1 over R1. So from this now, if we make our V1 the subject formula, so if we make V1 the subject formula, so that means our V1 will be Vt R1 over RT. So from here now we can also recall, so let's recall that RT, so RT can also write it as our R equivalent, assessing the same thing, is equals to R1 plus R2. Exactly. So we are going to substitute this value into RT. So that means we are going to be having our V1 will then be equals to Vt R1 over R1 plus R2. And this is the value of the voltage that is flowing through the resistor R1, which is why we, like we said earlier, voltage divider rule. Exactly. We are trying to determine the voltage that will be flowing through this first resistor, because if the total voltage is coming here, once it gets here, the value here will be different from the value here. So how do we know the value here? How do we know the value at the second one? So now we've gotten the value at the first one. So putting the circuit diagram side by side, so we can also, let's analyze this. That means the V1, which is this, the voltage here is the total voltage, which is Vt, multiplied by the value of the particular resistor on that particular the value of the resistance of the resistor at that point, which is our R1, over the addition of the two resistors. Exactly. So that means we can also say that our V2 will be equals to Vt multiplied by R2 over R1 plus R2. Exactly. So that means once we want to get the voltage at this point on the second resistor, is the total resistor, the value of the total voltage multiplied by the R2, that means the same R2 here, over R1 plus R2. Exactly. So that's just how you go ahead with getting the voltage divider rule and getting the formula for the voltage divider rule V1 and V2. So the assignment I want to give you for this particular video is, we've gone through getting V1, so I want you also to follow the same process and get V2. Exactly. So once you get V2, you have to get this same answer. So, but I want you to attempt it and see if you arrive at this answer, and let me know in the comment section. So again, if you find value, please give it a thumbs up. Subscribe to the channel if you are yet to, like and share the video, and then if you have any question, let me know in the comment section below. So again, to round it up, just know that if you are to get the voltage divider rule, you are going to get it from resistors connected in series. Exactly. Like you can see here, when they are connected in series, that is when you need to divide the voltage. Exactly, because the voltage flowing across resistors in series are different. All things being equal, they are different. There's always a voltage drop. Exactly. But when you want to get that of current divider rule, you are going to use the idea of resistors connected in parallel. Please try and understand this. You might need to write it down so that it can sink in. I've explained it in the other video, but I need to say it again here. Exactly. So that is it for this video, and then I'll see you all in the next one. Thank you.